All right, so let's go ahead and try an example here in thinking about photoelectron spectroscopy. So let's say we're looking at an element and we have an emission spectra and we know that it has 5 distinct different kinetic energies in that spectrum. We might be asked, for example, to determine what all of the different elements could be that would produce a spectrum that gave us 5 different lines. So the first thing that we want to do if we're thinking about something like this is just to determine what are all the possible, or exactly what orbitals are causing the 5 different lines that we're seeing in the spectrum. So if we're talking about 5 different orbitals and we're talking about a ground state atom, we know that we just need to start at the bottom and work our way up. So our first orbital that an electron must be coming from is the 1s. What comes after that? All right, then what? Oops. Yep, 2p. After that, 3s. Next, 3p, and that's 1, 2, 3, 4. That gives us 5 different options, 5 different orbitals, 5 different energies right there. So then all we need to do to determine which elements that corresponds to is take a look at our periodic table. So we want to look at any element that has a 3p orbital filled, but that does not then go on and have a 4s, because if it had the 4s filled, then we would actually see 6 lines in the spectrum. So that is relevant for all of these atoms here. So we actually have several different possibilities. It could be aluminum, silicon, phosphorus, sulfur, chlorine, or argon. Any one of these different elements could actually produce a photoelectron spectroscopy spectrum that has 5 distinct lines. If I went on and told you what the different incident light was and what the electrons were ejected with, and then you could look up the ionization energy for the particular different elements, you should be able to actually determine exactly which element it is. But just with the information given, we can only narrow it down to these choices here.